This is part 2 of section 3.6. We need to solve this inequality. First thing we do is we get a 0, which we have, and then you want to factor this side. Well, this factors as 3x minus 1, 3x and a 2, and that's going to have to be a plus, right? So that would be negative 3 and 6. Yeah, that's right. Greater than or equal to 0. Okay, now to do our number line to create our chart, we need to figure out which gives us zeros on each of these. If I set this equal to 0, I get 1/3. And here, if I set 3x plus 2 equal to 0, I get negative 2/3. Okay, so let's draw a chart. Well, I'll start with our number line. I'm going to put negative 2/3 first, and then 1/3. Extend this down. I'm going to put 3x minus 1 here, 3x plus 2 here, and finish the chart. Okay, so I need some test numbers, and I just need a number smaller than negative 2/3. You can pick any number. If you're not even sure what this value is, but you're pretty sure negative 1 million is smaller than that, you could use that. But we're only interested in the sign, and negative 1 is smaller than that. Now, I have two fractions here, and you might be worried about finding the number between, but I'm not, because this is negative and this is positive, and that means there's a 0 in there somewhere. And then a number larger than 1/3, I'll use 1. Okay, now let's figure out the signs here. If I plug in negative 1 here, negative 3 minus 1, that's a negative number. Negative 3 plus 2 is negative. Plug in 0. 0 minus 1, that's negative. 0 plus 2 is positive. Plug in 1. 3 minus 1 is positive. 3 plus 2 is positive. All right. Negative times a negative, that's a positive. Negative times a positive is negative. 2 positives is positive. Okay, so now let's look to see whether we're looking for a positive or a negative answer. This is supposed to be greater than 0, greater than or equal to 0, so I'm looking for where it's positive, which is here and here. And am I allowed to equal 0? Yes. So I'm going to use a bracket here and a bracket here. So my answer in interval notation would be negative infinity up to negative 2/3 with a bracket, union a bracket 1/3 to infinity. And then your graph of your answer would look like this. Okay, let's solve this inequality. 3x squared minus 5x is less than or equal to 0. Okay, we need a 0, and we have that. Now we want to factor this. I can factor out an x, and it gives 3x minus 5 less than or equal to 0. And then if I set each of these equal to 0, I get x equals 0 for this. And this one, I solve that, and I'll get x equals 5/3. Okay. So I'm going to put 0 here and 5/3 here. And then x and 3x minus 5. All right, I need a number smaller than 0, so I'll use negative 1. I need a number between 0 and 5/3. Well, this is an improper fraction, and so I know it's bigger than 1, so I'm going to use 1 right here. And 5/3, if you think about it, that's 1 and 2/3, so 2 would be on this side of that. Now, if I plug in negative 1 here, that's negative. Plug in a negative here, that would be negative 3 minus 5, which is negative. Okay, now plug in a 1, that's positive. 3 minus 5, that's negative. 2 is positive. If I plug in a 2, that would be 6 minus 5, which is positive. So following your sign rules, you have positive, negative, positive. Do these always alternate? No, of course not. But does it happen a lot? Yes. Okay, so now I need to figure out what I'm looking for. I'm looking for this thing to be smaller than 0. So for the first time, I'm actually looking for my negative answer. Am I allowed to include these endpoints? Do I use brackets or parentheses? Well, this has an equal to on it, so it's going to be brackets on both. So your answer in interval notation would be bracket 0, 5/3, bracket. And then just place these on the graph and shade between. Okay, now let's go into rational inequalities. These are different, but they are very, very similar. We still want to have a 0, okay? You also need to make sure that you only have one fraction. Now that means if this number is not a 0 and you need to move something over to the other side, you're going to have to get a common denominator and combine them. Okay. And also the other thing you have to remember is that whether this is a greater than or equal to, I would never be allowed to include 2 in my answer because it would give me a 0 in the denominator. So I still have to be aware of that. That's an extra thing we have to worry about. But right here for this first problem, we have our 0. We have only one fraction. Okay. Now, what you want to do is you want to make sure the top and the bottom are as factored as possible. And neither of these factored. And then you're going to ask yourself what numbers would make both of them 0, just like we did before on the other factors. It's just now they're on the top and the bottom. Well, if I plugged in a -5 here, I would have a 0. And if I plug in a 2 here, I have a 0. So just like on the previous problems, I'm going to make a number line chart out of these two values. Put -5 first and 2 second. And I'm still going to put my factors over here on the side. And the reason this is so similar when we have a fraction here instead of a division is because our sign rules for multiplication and division are the same. And really all we're worried about here are the signs. So, you know, it serves exactly the same function. I still want to pick numbers in each region. So a number smaller than -5, I can use -6. There's a 0 in here. A number larger than 2 would be a 3. All right, -6 plus 5 is negative. -6 minus 2 is negative. 0 plus 5 is positive. 0 minus 2 is negative. 3 plus 5 is positive. 3 minus 2 is positive. Just using our sign rules, 2 negatives gives a positive. 1 of each is negative. 2 positives is positive. And now, just like before, we look at the sign finally to see what it is we were looking for. We're looking for this thing to be strictly greater than 0, not allowed to equal 0 at all. And so that means we're looking for our positive answers, which are here and here. And we would never be allowed to include this one. This one was always going to get a parentheses because it comes from the denominator. But since we're not allowed to equal to, we can't use the -5 either. So our answer in interval notation here would be from -infinity up to -5, parentheses, union 2 to infinity. And then if you place these on your graph, and then shade, you have your complete answer there. Okay, so let's do this one. I have 3x plus 5 over 6 minus 2x, and I want this to be greater than or equal to 0. So I have the 0 I need. I have only one fraction, which is also good. Now I look at this to see if I can factor anything. That doesn't factor. Here I could factor out a 2 if I wanted to. I could factor out a -2 if I wanted to do that as well. But since this doesn't really involve an x, it's not absolutely necessary. I'd say factor it out if you have something that's nonlinear. All right, but what makes this 0? That would be a -5/3. Set it equal to 0 and solve, you'd get -5/3. What makes this 0? A 3. Because if I plug in 3 here, that's 6 minus 6. Okay, so I make my number line, and I need -5/3. And I need a 3. And 3x plus 5. And I can do 2 times 3 minus x. Okay, now the reason I say this 2 doesn't really matter is it never changes the sign. Because it's a positive number. So whatever the sign of this is the sign of my answer. I need to test a number smaller than -5/3. I can use -2. I can use 0 here, and I'm going to use 4 here. If I plug in -2, that's going to be -6 plus 5, which is negative. 3 minus a -2 would be 5. So this is positive. 0 plus 5 is positive. 3 minus 0 is positive, so this is positive. 12 plus 5 is positive. 3 minus 4 is -1, so this is negative. So overall, I have negative, positive, negative. And I am looking for this thing to be greater than or equal to 0, so I'm looking for positives. This says equal to, so I need to decide what gets a bracket and what gets parentheses. The 3 came from the bottom. It gets parentheses no matter what. 5/3 came from the top, and it has an equal to on it, so that can get a bracket. Your answer here in interval notation is bracket -5/3 to 3 parentheses. And just place that on your graph and shade. And you're done.